Hello everyone. This video walks through completing Packet Tracer Assignment 3.2.1.8, Configuring RIP version 2. This Packet Tracer assignment is a part of the Cisco RNS Routing and Switching Essentials curriculum. Now, in this particular lab assignment, we learned how to configure a dynamic routing protocol called RIP. We are specifically configuring RIP version 2. Now, as you note in the lab assignment, it says, although RIP is rarely used in modern networks, it's still a good foundational activity to learn about how dynamic routing works. You just came out of a chapter in chapter 2 which focused on static routing. So we had to, we want to carry all those things forward. Remember, a router only knows about what it's directly connected to. For instance, R1 here knows about, let me see if I can draw a box here. R1 currently knows about this network, the one it shares with R2, and this one down here, including that little interface there. All right, so that's the three networks R1 knows about. Anything I didn't draw a box around, it does not know about. So in chapter 2, we had to go in here and say, hey, R1, if you want to get to 192.168.4.0 on the other side of R2, I need you to send all the traffic out of this interface. And then R2 will know about it because it's directly connected to it. So it's kind of filtering the traffic or directing the traffic, almost like a traffic officer, or you're directing airplanes on a runway. You're directing stuff in the right location, the right way, the right path. Now, we did see that static routing, even though that'll work, that gets very cumbersome because R1, I'd have to enter many networks. I'd have to enter, 3 different remote networks that it needs to know about. But what if a path changes or something? It's still going to try to send it because of the static nature. It thinks that we manually configured that. Now, with dynamic routing, what you do is you advertise all the networks that you know about as yourself as that R1, and then you share it with R2. R2 does the same thing. It shares its information with R3 and R1, and R3 will share it with R2 and R1. So it's kind of like it's building a list, kind of like you share information with your friend or something to say, hey, these are the people I know. What people do you know? Where do you know how to get to? And then we kind of build a list on top of each other. So dynamic routing can also change depending on if links go down or come up. And usually you have a combination of static routing and dynamic routing. You'll kind of see that in a minute. Now, let me remove these boxes. Now, I want to show you a little image here. This is in your reading. Your directly connected routes, meaning ones that are directly plugged in. Remember, when you do a show IP route, you'll see that table in there. Every entry is a network that you know how to get to as that router. If it's directly connected, its administrative distance is 0. The lower the administrative distance, the more preferable or priority that route has, okay? Especially if there's more than one way to get to a location. If it's a static route, meaning you manually entered it in there, it's assigned a 1, okay? That means that it thinks that you needed to know how to get there so bad that you put a manual route in there, or that specific way that you wanted to follow. If it's learned about through EIGRP, just normal EIGRP that we'll learn about later, is assigned a 90. We're not going to go through what a summary route is quite yet, but just know EIGRP is 90, and we won't actually configure EIGRP this semester. EIGRP is a dynamic routing protocol that is used for large networks. OSPF is also used for medium to large networks, and there's a lot of different things we can get into with that, but again, that's a next semester topic when you get to scaling networks. All right, so again, that was assigned to 110. And lastly, you see RIP is not very preferable at all. It's down there at 120. The reason being is because RIP only thinks about hop count. How many hops or how many routers do I have to touch to get to my destination? It doesn't think about link speed at all. So if it takes 2 hops to get to one place, and they're both dial-up, but it takes 3 hops to get to that same place going another route, but maybe it was like 1 gigabit per second extremely fast, it's still going to choose a slow route, even though its dial-up speed is only 2 hops away. That's what it uses as its metric, is what it's called. So just wanted to share that little diagram with you. So we're going to be configuring RIP version 2. Now, RIP version 1, you have to use a specific subnet mask that goes along with the address. You know, with IP version 4 running out of addresses in the American registry anyway, we are looking at RIP version 2, which allows you to change that subnet mask, which we learned in our first introduction to networks class through variable length subnet mask. So we're going to use RIP version 2. So we're going to go through how to configure that. So on R1 here, enable configuration mode, and we are going to use the appropriate command to create a default route on R1. Now, if we remember the default route, and again, that's how we get to the outside internet. Kind of think about R1 is like an edge router. Before it gets to the outside world, we're not going to control what the internet does with it, but we want to configure that default route. Remember, a default route is all zeros. Just that's what you should think when you hear default, all zeros. So 0.0.0.0, 0.0.0.0. Okay, that means if I don't know about something, this is the way I'm going to send it. It's called a gateway of last resort. So it's going to send it out to the internet if it doesn't know about something, but it still may or may not get delivered. It just puts the responsibility on somebody else. So we're going to send it out of serial 001. That's that directly attached method. Don't worry about that. That's not an error. It's just telling you that it could affect something way later that we'll configure in like the 4th Cisco class. All right, so IP route, all zeros, send it out of serial 001, which means R1 is going to send it out here to the internet if it doesn't know about it. Okay. Now let's get to RIP. All right, that was kind of a review from static routing. So the command is router RIP. You hit enter, and you notice it changes to config-router. Now we're going to type in version 2. Because we wanted to use version 2, it will use version 1 by default. It also says disable the summarization of networks. So we're going to type no auto summary. What this does is it basically makes your routing table easier to read when you do a show IP route. Now we're going to configure RIP for the networks that are connected. So that's why I said the directly connected networks. All right, so we've got our network statements here. So we're going to put network 192.168.1.0. Okay, hit enter. Network 192.168.2.0. Now we're not filling in anything for this network that's connected to the internet because that's something that we really don't control. That is, if we don't know anything, we're going to send it out to the internet if we don't know where we are going. Okay, so again, those are the only two that we want to put in there. All right. And then we're going to configure what we call a passive interface for E. It says configure the LAN port. All right. We only want to share routing updates with other routers. There's no need to send this routing update for RIP to S1 and PC1. They're not going to do anything with it. It's just going to waste bandwidth. So right here, we've got G00. So the command is passive interface G00. And hit enter. So there's no need to send that out. Okay. Lastly, it says advertise the default route with your other RIP routers. The command to do that is default information originate. Oh, had my dash in the wrong place. All right, default information originate. So what that tells it is R1 knows if I get something in from anywhere that I don't know how to get to and I don't have an entry for it, I'm going to send it out to the internet. Well, what about R2 and R3? They need to kind of know the same thing to say, hey, if I don't know about something, I'm going to send it to R1 and let them send it out to the internet. So by default, your default route that we configured up here is not sent out with RIP updates. You have to put in the default information originate command to make it send out that default route to R2 and R3 to say, hey, you guys, if you don't know about something, send it to me and I'm going to send it out to the outside internet and hopefully they know how to get it to where it's going. Okay, that's pretty much it. Exit. I'm going to copy, run, start this. Just save it. All right, and now I'm going to move on to R2. Now R2 has 3 directly connected networks here. So we're going to do enable, config T, and we're going to do router RIP. Remember, it's going to get its default route from R1, so no need to put one here. All right, router RIP version 2, and we're going to do no auto summary again. Okay. We're going to configure as directly connected network. So we'll do network 192.168.2.0. Now I know you're like, well, we just entered 2.0 on our R1. Well, yeah, it's directly connected to both. So we have to make sure we advertise all directly connected networks. Do the 3.0 network and the 4.0 network. Okay. Now we still want to put our passive interface here for the LAN, because this is a local area network it shares with S2 and PC2, and that interface is G00 as well. So passive interface G00, and that's it for this one. So we want to do a copy, run, start. All right. Now lastly, and again, we don't have to do the default information originate command here because we don't have a static route on R2. It's going to get its route from R1. And in the end, we're going to look at what this routing table looks like once it's fully converged. And converged means all the routers are up to date. So then lastly on R3 here, we've got router RIP version 2, network 192.168.4.0, and network 192.168.5.0. Okay, and then we're going to still do the passive interface for G00. That should be the name of this interface right here, and it is. So passive interface G00. Oh, and that's it. I'm going to copy, run, start it. And whoops, I did forget one command here. Let me go back into router RIP and type in no auto summary. We did that on the other two, but we forgot to on that one. Okay, so if you notice, that gives us 100 out of 100 for the lab. All right, now it's great we got 100 out of 100, but let's make sure, I'm gonna fast forward time a little bit. I'm gonna make sure everybody can talk to each other. So for instance here, PC1 should be able to talk to PC2. It may fail the first time, but we should get a successful. PC1 to PC3, refire it, we get successful, and then we want to check the other directions, right? PC3 to PC2, all right, PC2 to PC3. Okay, so we got all connectivity there. All right, now let's try PC1 to the web server. All right, fail the first time, we get successful. PC2 to the web server, PC3 to the web server. So we got connectivity everywhere, so that's awesome. All right, now let's look at our routing table. So we're going to exit back out one, and we're going to do a show IP route. Now our routing table here for R1 shows everything we know how to get to as well as how we learned about it. So C is directly connected. That 1.0 network is directly plugged in, right? Same thing for here, the 2.0 directly plugged in. Now you start to see the R's. That's where we learned about it from RIP. So it knows about the 3.0 network, the 4.0 network, and the 5.0 network, all from RIP, from the other routers. It also has your static route down here, your default route, okay? That's what the asterisk means, is it's a static default route. Which means if I don't know about something, any network that I don't have in this table, pretty much anything besides those, 1, 2, 3, 4, 5 networks, then I need to send it out of serial 001, which goes out to the outside internet. The web server, you can see its address doesn't fall into any of those categories in this table, okay? So if PC1 sends it out and R1's like, hey, I don't have that, you know what I'm gonna do? Send it to the internet. And hopefully they know about it, which they do in this situation. Same thing for PC3. R3, if we look at its routing table, okay, it shows that it learned its static route from RIP, okay? So it's got an R asterisk, that means candidate for default route, and we learned about it through RIP, okay? And then you see its directly connected ones as well as its other ones that were learned through RIP, okay? So when PC3 sends something out to the web server, R3 gets it and says, I don't have 64.100.0.10 in my routing table at all, but you know what? I'm going to send it out of this interface to get it eventually to R1, and R1 is going to send it out to the internet. So it's kind of like a gateway of last resort. It doesn't always guarantee that this internet knows about it, but it puts the responsibility on somebody else. So hopefully connectivity can continue. And then lastly, we'll do a show IP route here on R2. Okay, so you see the same thing here. Its default route was learned through RIP. All right, you got your other RIP routes in here, networks directly connected. All right, so again, that completes configuring RIP. RIP is only used for small networks though. Remember some of the limitations. If you have something more than 15 hops away, once it reaches that 16th hop, it basically deems this unreachable or infinity and it drops it. So RIP is usually only used for small networks. But again, you kind of see how things are shared much easier here than static routing. But there are reasons to use both. Usually we use a combination of dynamic and static. So hopefully that helped you kind of understand RIP. And much later in other classes in the scaling networks and connecting networks, you'll learn how to configure EIGRP and OSPF multi and single areas.